have released the next version, number 3, or GIF Next, as it is called. And this release contains a number of important improvements and developments, and Matthias will dive deep into the details. And welcome, Matthias. The stage is yours. Thank you so much.
Thank you, Christoph. Oh, better? Okay, yeah, I guess. So, nice to see you here. My talk is about our insurance platform, the version 3 of the GIF, the framework, basically the blockchain part that is below what we built. The outline of my talk is first a short intro in the problem statement and what we want to build. Then, as mentioned by Christoph, look into some of the features that will come with the version 3 that we have built over the last year. And at the end, a brief glimpse into a live product that is built on version 3, basically a relaunch of the flight delay that was the original product that made Etherisc famous in the blockchain space. So if you have been here in 2016, then you might remember that use case. So it's kind of fun to revive that thing on the latest version that we have. Okay, intro. What is wrong with insurance? It's working very well in developed countries. In many other places, it doesn't quite work so well. So why is that? It's billions excluded from access, sometimes as a result from not having access to financial services at all, sometimes because distribution is not there, or the classical insurance industry doesn't care, or normal people not having access to financial services, it's just too expensive to onboard them. So it starts with very minor things and excludes a large amount of the population around the globe from access to financial stability. Another thing that is wrong is insurance usually, even if it's there, it's slow and expensive, which makes or kills even many of the use cases that would add financial stability to a large part of the population. And at the end, lack of transparency. Insurance is very often a very asymmetric game. So insurance knows a lot about things and a lot about you. You as the customer or the policyholder, you hardly know anything. And especially, usually you don't know the fine print. And then, as you mentioned also, the claims are bold. And then you go for the claims. And when you actually are asking for a payout, they show you around in the fine print. And then, oh, unfortunately, this was excluded. So you were not signing up for that. So what do we want to do? Our mission is basically make insurance affordable, transparent, and accessible, and that based on blockchain technology. Vision is building the platform that is fast, efficient, secure. So basically, if you have an insurance use case that you want to build on top of the blockchain, the Etherisc platform should be choice number 1. Not because we really want to sell something to you, but we'd rather prefer that if you check it out, if you look at it, it makes you aware that building on top of our platform makes you faster, more efficient, and more secure. Because what is an insurance? It's basically a huge number of small building blocks that just repeat themselves and again and again. And the difference is much more in the use cases than in the actual mechanics of an insurance. And the actual mechanics of an insurance, this is what we want to take care for in our platform. If we compare to other stakeholders or other players in the field, we can see that Etherisc, on the top right, is basically alone. So we're currently the only one that provides an insurance platform that is not use case specific, that should help people that want to build on top of blockchain insurance use cases, should make it very attractive to build on our platform. So basically pioneer and first mover, and for reasons are not really clear to me, we're still the pioneer and first mover in that space. This has worked very well in traditional industry, let's say SAP, or if you really go into the insurance industry, you'll find companies like Guidewire that have a huge market, and the only thing they do is provide ERP systems that need then to be tailored to specific companies, and there's a huge consulting market that also takes care of that. So it's a huge amount of untapped resources that hopefully sooner or later will come and play into what we are actually betting on. What we also see on this is that all you guys that are here but presented before, the space is so big and the pie is so big that I think there's absolutely no competition so far. So almost every guy here, every project that presents itself here is a first mover in their own space. So it's much more interesting to actually collaborate than experience this as a competition between the players. It's still very early, so yeah, let's build on each other, let's help each other, and this is basically the fundamental message that we want to bring over. There's also a tech part, and this is basically why I'm standing here and not somebody else from Etherisc, which is the latest release. So a year ago in Istanbul, I was showing similar things with the difference. At that time, there were more ideas, concepts, and PowerPoints, and this time it's actually code that runs. And to the point where the flight delay that we have now live is basically built on this version 3 of the GIF. So what is the GIF? It's Generalized Insurance Framework. It's a set of smart contracts that you can use as a basis to build your own products in the insurance space. It covers the full insurance value chain from the application to policy to payouts, management of risk capital. Now also includes distribution in the sense of if somebody want to buy a policy, then that usually needs to be sold by someone, and that person is actually working to sell a policy, so that person should also receive some money. So the new features, as already mentioned, this distribution support we now include in version 3, which is basically taking care of that the people that sell insurance or policies, that they also they get benefits by getting commissions. Another thing that is new with version 3 is policies, and by the way, all other business objects inside of GIF that are have a certain relevance are modeled as NFTs. So tons of things that we have, they have an ownership, and why not just use NFTs to model ownership? It's so natural and so clear and so easy to use that we decided that most of the objects that we care about in insurance space or in our framework, we can model that as an NFT. So it immediately opens tons of markets. You can trade policies, you can sell policies, or you have all the options that you have with typical NFTs. And at the end, this is something that is becoming really relevant, especially in the last 2 years, is we're no longer just living on a single chain, but we have a cross-chain architecture. So we want to support a full L1, L2 ecosystem with the platform that we built. Let me dive a little bit deeper into things. So the first is, I mentioned that we capture the full value chain of insurance. I have a small example here, which is basically the simple thing of selling a policy. And by running through, it should become clear that it's actually not that simple. And it should also show what parts are covered by the framework and what parts, as a builder of an insurance use case, would be that you would need to take care of. We have here the policyholder with some money that's supposed to be the premium. And then we have somebody that is going to sell an insurance to that policyholder. That guy does this with a referral code. So basically, when the policyholder wants to apply, he's using that referral code. So the first thing that is done here and supported by GIF is create and check the application. So there's an application object that will later be turned into policy itself, but it starts here in the product smart contract that like all the attributes from the policy are checked and make sure that they do work. Then the next thing is, if that guy wants a policy, then there's a sum insured attached to the policy. So somewhere there needs to be the capital to cover for the sum insured. And this is basically in the risk pool. And there needs to be enough money to cover the policy. The money comes from, in that case, from this risk capital provider that, let's say this guy puts 100,000 into a so-called risk bundle. Then this money of that guy is managed here. If there's a policy that needs to be covered and this bundle accepts the policy, first this one needs to have enough money, then all the bookkeeping is working and supported by GIF. So the capital to cover the policy will be put aside so it cannot be reused for something else unless the policy expires and again frees the capital. The next thing is that if we have the ability to cover the policy, then this guy is actually going to collect the money, the premium money. And it immediately splits the premium money. Some part, like you can say, I have a product fee, so that fee goes away. Then you have basically updates fee or whatever that guy wants, more fees that go away. There's a certain amount of the premium, of course, needs to be used as a risk capital addition, so that goes into the pool. So this pool is also updating all the balances to manage the risk capital, what is locked capital, what is non-locked capital. And finally, on the distribution side, This guy, let's say you have a referral code that can be used 100 times, I'm going to sell one, so you need to subtract one, so you have 99 use cases left. Then through the referral code, you would know which broker or distributor that was, so you can immediately move the money or the bookkeeping so that the commission that that guy over there gets is already booked in the distribution module. And at the end, when you've done all that, you can then create and activate a policy, which is basically a policy. Now, this actually is the policy holder. And except for the details on what product you use, almost every other step is generic and is supported out of the box from the framework. Of course, you can build your own smart contracts. They might turn out a little bit easier than what we have built because you don't need to have the full generic approach. But on the other side, most of the thing is absolutely vital to insurance, and somehow you would need to do that anyway. So why not just take all the stuff that is already there and just plug and play, add a little bit on top of your own code, and you're almost ready. So that's covering basically what the added value is of using the framework. Now, I mentioned that policies are NFTs, and also that almost everything else is an NFT. Let's start with here having, let's say we are here on the base chain, so there's a base registry. Basically, inside of the registry, we have the NFT contract for all things GIF that are sitting on the base chain. Also, there's a registry on mainnet, and it has an entry, which is again an NFT. So this is the chain registry on base, is on base at that address. Yesterday, there were talks about how this L1, L2 space is started to fragment it and how to include the chain ID inside of the address, which is a really, really cool concept because it basically immediately solves that an address is, per definition, also saying on which chain it lives, which would make this bookkeeping even more easy than it is today. So you can start in a single contract on mainnet, you will find the registry on base, and then once here, you find everything that is happening on this base chain. So for example, if you want to build a use case, you would need a so-called instance. Basically, this is where the data goes, and that is managed whatever you want to do with your use case. This is your anchoring point. How you can create an instance by just simply clicking a transaction, paying the transaction fee, and you have your own instance. This is permissionless, so everybody that wants to build on that, just you can create your instance and then you have the ground of that. Once you have that, you can add your pool contracts, your product contracts that you developed. Then the next thing would be you can fetch the money from investors or from some source that basically provides them the collateral. This is indicated by the bundles. And now your insurance is ready to start to sell policies. This would then be all these policies A1, A2, A3. And as mentioned before, all these things, even the bundles, the pools, the instance, all this is an NFT. So if you have your instance and this is an NFT, you can just simply transfer the instance to the next owner if you want. Or the same for the product. Or if an investor has a bundle, even including all the locked capital, because it's an NFT, the guy with the money and the locked capital does not need to wait until the locked capital is free again. You can just simply transfer or sell your NFT to another investor that shows some interest in what you want to do here. Now we zoom out a little bit to see the L1, L2 space. So we have again on the top left, we would have mainnet and we have the base network here. You can see that the chain registry of base points to the global registry, but then you can just add other chains and they would also point to the global registry. So basically this guy here is like a dictionary for the full GIF ecosystem or Etherisc platform ecosystem, and if you have access to this one, you basically have access to the full ecosystem down to policies and each individual item that is living in the space. So this we do not have so far. In the past, we were building on several chains, like Gnosis chain, like Polygon, and it's also kind of a fragmented thing. So if people are asking, where is your contract of this and that, you always need to dig up and look up at addresses. With this architecture here, you only need to know a single address, and from there you can basically dig through the whole space on complete L1, L2. Distribution support, this is one of the bigger features we add is version 3. What is distribution? never goes and buys just an insurance because it's cool. You don't wake up and say, today I want to go and buy an insurance. You might want to go buy some new clothes or a car, all the stuff you're looking forward, but insurance buying is, nobody's looking forward to buy an insurance. So the point is to sell insurance is always an active process. And the distribution and selling insurance is a huge industry on its own, which so far we did not really consider until this release. So there's a whole industry around distribution, and it's vital to insurance business, agents, brokers, their whole tech platforms that do nothing else than try to sell insurance to people. And on selling insurance policies, we need to acknowledge that selling policies is actually work. If it's work, it needs to be paid. So if somebody successfully sells a policy to somebody, or then they need to receive a commission because it's work. If you want to scale, you can also do this peer-to-peer. If you want to have a model where it's attractive to help to sell policies, you need to reimburse these guys. So always, whenever you buy insurance, a part of the premium you pay is basically the salary of the guy that sold you the insurance. The features is that it manages distribution fees per policy sale. So it says on how big the fee part is that you have on the premium. It manages commissions per policy sale through these referral codes that we have seen. And it's basically the distribution contract is also linked to the product contract. So if you have a product, you have a specific distribution contract that basically specifies how you want to handle the whole distribution part. And a lot of this, again, is generic, like referral codes and management, who gets the commission when you sell a policy. This is generic and already taken care of by the framework. The main objects we have is the distributor, which basically is like the agent or broker. It's a new stakeholder in the ecosystem that we have. These are the guys that sell insurances. If you have this role or this stakeholder, then you can create your own referral codes, and then you can start to go out and sell policies, and then, as a result, if you're successful, actually receive the commission. You have distributor types, so product can say, I have different types of like wholesale channels or retail channels, and some of these get more, they can offer more percentages, or some commissions are higher. You can give freedom there's a lot of degrees of freedom that is provided by the frameworks on how you want to set up your distribution mechanism. And the referral codes, they have currently very simple properties. I mean, how many times can you use a referral? Referrals can expire, so if you don't use that up until a certain point, then the rebate is no longer valid. This is things that you can do, supported by the framework. Okay, come to the end by the revival of the flight delay, version 3. This is the UI, how it looks. It's kind of super simple. You pick the airline, you pick a flight number, you pick the date when you fly. Then you will get some statistics on how reliable that flight is, and you get the payout option. So you get payouts when there's a delay of more than 45 minutes. You get a payout if the flight is cancelled or if it's diverted. From a process point of view, the first thing you do as a user, you select the flight, and then basically you get a price based on the historical details of that flight. If it's reliable, cancelled often, arriving late very often. What we use here is the off-chain part, is the flight stats API, which basically covers all the commercial flights around the globe. Once you have the statistics from that flight stat API, we can then use the smart contract to provide you the price, or basically the payouts that you get. Then the next thing is that you, as a user, you sign a permit. So the insurance or the product is able to fetch 15 USDCs from your account. And so you don't need to pay transaction fees, because with this permit, the whole thing, that on-base transaction fees are basically zero, so we can easily sponsor them. So we have just a process that then takes your permit, collects the money, distributes through the different stakeholder, and moves the remaining money to the risk pool, as mentioned before. So what the framework is doing is basically doing risk management. Risk management in that sense is a flight is a risk. Because many people can buy a protection for the same flight, and then we want to avoid cluster risk. So we have a limit that says, yes, you can get a protection for flight XYZ, but then if 20 other people would also be on that flight, and then that flight is delayed, there would be a huge payout on our side. Because it's demo mode, you have set the cluster risks really low, so we can, if you have a $200 payout, you currently can buy 3 policies for that specific flight. We did not yet run into such a configuration, but this is just how, this is about risk management, so every policy is attached to a specific risk, and in the case of the flight delay insurance, a risk is a flight. And the risk capital management, we already came across. Basically, it reserves the remaining money for the max payout, because if you pay $15 and you have a max payout of 200, if we start the program, there's no way we could pay out this $200 if you would not have risk capital to start with. And the whole handling of that is also taken care by the framework. Premium collection, distribution, policy creation, policy activation, and then specific to flight delay, create an Oracle request. Because if I protect flight XYZ, I know when that flight is scheduled for landing, so I can set a timer 1 hour later, and then I can go this 1 hour later, I kick again FlightStats API and ask about the status of that flight. Was it on time? Was it late? Was it diverted? Was it cancelled? At the end, you don't need to do anything, you just receive a payout or not, depending. When it's on time, you don't receive a payout. So I mentioned before, the FlightStats, the data of the status of the flight is fetched from FlightStats API, and because it's a parametric insurance, we have to say the fine print in that case is we don't care what your flight did. Your protection is based on what FlightStats API is telling us. So both sides need to agree that the true source for a payout or no payout is not what actually was with the plane, but both sides agree that I'm happy with the data that is basically reported by FlightStats API. You could do more complex products like adding an optimistic oracle where you can challenge if you're not happy, but then, that's too much for a prototype. It just mentioned optimistic oracles, that is something that you could add to a parametric insurance, that if you're really not happy or this is really getting bad, then you actually have a path to a resolution that is partly off-chain, and this is also something like Kleros would also be a protocol maybe that could be used for something like that. There's some options to do that. Anyway, so you get the Oracle response. From that on, it's mostly framework again. Then you have the risk management, because you can then remove that flight from the risk. You basically can put the risk in archive mode. You do the payout and the claims handling. If there was some money left, then you can release the capital again to the risk pool, so the capital can be again used for new policies. And at the end, it's policy expiry or closing. So policy expiry closing, of course, in any case, even if the flight is not late, it just basically means for the risk capital side that the money is free again for new business. Yes, so that's the overview of flight delay. And at the end of my talk, thank you so much.
Thank you, Matthias. Any questions to Matthias? Yeah?
Hi, hey, Matthias, thanks for the talk. I have 2 questions. The first one is for the flight insurance, I saw this mention of FLTD. What token is that?
This is from the test instance, so it's like the flight delay dollar.
Okay.
It's basically a fake USDC. It's just an ERC20 token to do tests.
I see. So it's supposed to be like a stable coin.
In production, it's USDC.
Okay.
So you pay by USDC, and the payout also is in USDC.
I see. Okay. And then my second question is the flight delay insurance. How does it compare in terms of cost and compensation compared to like real world insurance? If we buy from, let's say, a traditional insurer for flight delays, right? How does the cost compare, and what is the compensation comparison as well?
This goes into the business of flight delay, and I'm inclined to let that question pass myself and go to Christoph. How does this compare to traditional insurance from the pricing?
From the pricing, the pricing here is pretty simple. So we have a FlightStats database, and this database gives us the delays from the last 3 months. Yeah, so we have typically a flight number, let's say GF 86. This is the flight which I have taken to Bangkok, and we have this flight number is every day. Yeah, so in 3 months we have about 60 flights with this flight number, and so we have a statistical entity of 60 flights with 60 different delays, and so we can very simple calculate the average delay. And so the probability of a delay is just the number of flights and divided by the number of delayed flights. So it's very simple, and this is the expected loss. So we take the expected loss. So this would be the zero-sum game. Yeah. So if 1,000 people insure this flight, and for 3 years, then and they would pay exactly this probability as a premium, then this would be a zero-sum game for everybody because of statistics. So on top of the expected loss, we just add some margin for operations and also for profit, and also, due to statistics, this is exactly what we will have in our wallet after 3 years. So, of course, there could be a catastrophic event like this volcano, which has erupted on Bali, I think, and which will delay all of the flights in a certain region, which would be an excessive loss. And so, for this, ideally, we would have some reinsurance. Yeah, so some which would cover the so-called long-tail risk, catastrophic events or excessive losses. And so, our business model is based on the average, where we have, and it works best for retail, high number of insurance policies and comparable low premiums, and this is the traditional insurance business case for retail investments.
Yeah. I wanted to ask about the reinsurance. So you are trying to create also the reinsurance policies, or is to be reinsurance by a traditional finance reinsurance company?
So this is our own model. So there is no insurance company behind. So this is just a smart contract with a risk pool, which is funded by us, and so it's legally, if you ask the question, it's legally a German special legal model which we have somehow aligned with our regulator. So we are allowed to do this on small scale for this pilot. We would not be able to do this on a huge scale because then competition would come up and would say, hey, you are not an insurance company, you should get a license. So we are allowed to do this in Germany with a special alignment with our regulator. It's not allowed to do this on large scale, but it's our own model here.
Yeah. That's a very nice question because it allows me to ask two more points I didn't mention. I mentioned that the policy is an NFT, so you can do both, like traditional reinsurance or on-chain reinsurance if you want, because we also added the fact that this NFT can be held by a smart contract. So basically the risk pool is a smart contract. So the risk pool itself could hold the NFT of a policy where the insurance is actually the reinsurance. So this works in a way that if a smart contract is a policy holder, then there are callbacks to this contract. So which would make the receiving contract aware that a policy has been sold or a payout has been received. So you can basically, if you want, you can model the full insurance, reinsurance use case all on-chain with the current version.
Any more questions? Okay, thank you so much, Matthias, and